Hello everyone, this is Hoda Ganji. In this video, I'm going to show you how we can create a perforated surface. So I'm going to open a new project. Let's go with default metric. I want to change units to meters before I start. I prefer meters when working with Dynamo because the numbers in between 0 and 1 would make sense. So I'm going to go to Dynamo. Let's open a new project. So first I want to create a surface. I'm going to maybe use a set of points. How about I assign a sequence here, and I want another sequence on the Z direction that goes there, and I would like to use a cross product for the lacing, so it goes with maximum number of points possible there. And feel free to assign a number slider. Actually, I want to go with integer slider, so I want to change this up to 1. This is going to give me the number of points. Let's say at least we're going to have 5, at most we're going to have 30. And I'm going to copy and paste this, Control C, Control V. And I want to assign this to my amount here and amount here. So now it's more kind of parametric. Okay, so let's go with this. And this is my set of points. And just to show you that actually the surface that we are going to make punches, holes in it, does not have to be flat. I'm going to go with a NURB surface just to show you that you can cut objects from any surface, basically. So how about I go with geometry, surface. I want to go with a NURB surface by points. So NURB surface by points, this is what I'm looking for. Okay, but before assigning this to this, I want to make this a little bit curved or something. So basically you're gonna see how it works on a curved surface. So how about I go with some shape here. I want to go with like an ellipse. Let's go with an ellipse, and I'm going to consider it as my attractor, an attractor geometry. So we have by origin and radius, that's good. I'm going to go with this. I'm going to put it somewhere around the middle over there. So how about I go with half of this number, maybe divided by 2. So I want to locate it somewhere around the center. So I'm going to bring a point. So this is going to be the origin for the ellipse. This goes to X, and to the Z I want to divide the other number by 2. So again it's somewhere around the middle, and I'm going to assign it to Z. So this goes to my origin, and that would be the ellipse. And actually I need to have a node that allows me to have the ellipse in the XZ plane. So let's type ellipse, see what other options it's gonna give me. We have by plane. Actually, I don't see anyone with a normal. Let's check it here. If I go to curves, ellipse, and no normal here, no normal here. So we're gonna create it, and then I have to actually rotate it. That's fine. And I'm gonna assign 2 number sliders to X and Y. So how about I go with a slider here, and I'm gonna assign this to my radius here. So this is gonna change easily. How about we assign a minimum of 1, a maximum of, let's say, 30. I want to copy and paste this last node, the number slider, and assign it to Y. Now we can make it smaller. Okay, now I would like to kind of rotate this ellipse so it's kind of aligned with our surface. right, which is on the XZ plane because the points are on the XZ plane. So in that case, I would go with rotate. We're gonna rotate the geometry, right? So the third option gives me the rotation of a geometry. The origin is the same point that we created. The degrees is gonna be 90, so this goes to degrees, and the axis, let's see, we wanna rotate it in this direction. So probably if I assign the x-axis, it should work, but if it does not, we'll change it. So I'm gonna go with x. I'm gonna assign this to the axis here. And as you see, it's rotated correctly. That's good. I'm gonna hide this other one. So I'm assuming this ellipse as my attractor geometry. I'm gonna make it a little bit smaller. Also on this side maybe. Okay. And maybe I can go with a divided by 2 minus 0.5. And minus 0.5 here, so it's a little bit more to the center. Okay, this seems good. Okay, now just to see a little bit more clear what's going on here, I'm gonna group these items. This is my attractor geometry, and this is my original set of points, right, or a grid of points. I wanna maybe group this as well. Grid of points. I want to move those points in the normal of this XZ plane, which is in the Y direction, based on the distance from the attractor. Okay, so I want to go with move. It's going to be translate geometry, which is point goes to geometry, and I want to get the distance between the attractor and the point. So let's go with distance to this point and this point. This goes to other, and this is going to be a very big number if I connect it to Y. And how about I turn the preview off? This is going to go to our nerve surface, and let's see it here. It's now a little bit too exaggerated, right? So I want to reduce the amount of curve, right? So I want to go with like a divided by let's say 5 or something. I want to make this number smaller and then assign it to the Y translation. So now the surface is more reasonable. Maybe I can go with divided by 3 or 2. I'll go with 3. Okay, now it's better. If you want to know how much this surface is moving back and forth, the best way to do that is to go with the minimum of a list, right? Because you have a list here. If you go with minimum item and maximum item, actually minimum is probably 0 or around 0. Maximum item. If you connect this right now to the minimum maximum, it's going to give us a list because it was a list inside a list. So actually before doing this, you need to flatten it. We're just going to get the lowest number, right? If I flatten it, assign it to maximum, you see the maximum movement in the Y direction before was 2.98. After I divide it by 3 is 0.99, which is less than a meter. I'm going to keep it less than a meter, so this is good. And you can also check the minimum, which in this case is very close to 0 or 3 centimeters. Okay, so this is just for your information. Feel free to delete these nodes. I don't want to keep them. And I want to leave the points here. So I just wanted to have this surface, right? And then I want to cut some geometries out of it. So how about I group these items and name them as my nerve surface. So these 4 nodes here, my surface is here. Now, so far we have a set of points. We have an attractor geometry, which is that ellipse over there, and based on that geometry, we moved them back and forth in the y direction, and we made a NURB surface out of the points. Next, what I want to do is that I want to create a set of geometry and cut it out of the surface. Let's say just some cylinders. Okay, now I can go with a new set of points or something. I want to have more than one item. I want to have a list of items which are cut out of this surface. But I could also use a new set of grid. But I'll go with the same points, so you see that you can use the same set of points. So make sure to save your file. So let's create a set of circles on each of these points, right? How about I go here, continue working up here. So let's continue from here. I want to create some cylinders. You can type cylinders, see what options we have. We have by radius and height, by point radius, and so on. Actually, I think it's easier if I go with circles and then extrude them. I want to go with circles by center point, radius, and normal. So if point goes to center point, the normal is the normal of the XZ plane because the points are on the XZ plane. So the y-axis is our normal. I want to bring a y-axis, assign it to the normal. And to the radius, I just want to assign one number. I don't want to make it too complicated in this tutorial, but feel free to go with random numbers for the radius or something. So we have a set of circles. If I extrude them, and I want to extrude them as solid. Okay, I want to go with extrude as solid distance. That goes there. And now we have a set of objects here, right? So we have our surface. And maybe I can hide some stuff here. I want to hide the points. I want to hide this point here and the ellipse. Okay, so if you see here, the objects are cutting the surface, so that's good. Now I want to go with trim right now, and it will not work, and I'll let you know why and how we can fix it. So what I want to do is that I want to cut these solids out of the NURB surface. Right? So if I go with cut, difference, boolean, whatever you go with, you see that we have different subtracts. One of them is like difference here or here. Actually, this one and this one, difference and difference sol. These are about cutting two solids out of each other. Let me type again. Difference. There is also a difference which cuts surfaces out of surfaces, but what we are looking for is cutting solids out of a surface, right? So I want to go with this one. So read the inputs and outputs, especially the inputs, and see which one you need. I'm going to go with subtract from, surface goes to surface, and I want to connect, you see this is reading solid. I want to connect my solid to the trimming entity, and it will not work here. So first you need to hide your objects and the original surface to see if it's cut or not. I also want to cut or hide the circles maybe. You see the surface is not cut, right? There are several reasons. One of them is that we have a number of solids here, but this is actually assuming that we're gonna assign one solid, so we're gonna have to go with flatten or union. Another thing is that the objects that we had here, they are not exactly in the surface. Some of them are on the edges. Okay, so what I want to do is that maybe I want to scale the whole thing, scale the whole cylinders actually. So let's see what scales we have. We have a scale geometry. I want to see if there is a scale based on the point. If it's not, we'll go with just regular scale. Okay, that doesn't seem like it, so I want to just go with scale, geometry, and amount. I was looking for a scale which will allow me to select a point as the origin of the scale. Okay, so let's go with scale, geometry, and amount. Geometry is the solids that we have here, so solid goes to geometry. Amount, I'm going to assign, let's say 0.9, and we'll fix it if it's not working correctly. So that goes to amount, and now it's going to be all over each other, so I'm going to hide the original one. Now let's see. The second set, which is here, I also need to move it because this side is now not on the edge, so it can be cut, but this side is still on the edge here. You know what I mean? So I want to move them a little bit to the right and a little bit up, and maybe I have to make them even a little bit smaller because there's still not enough room to fit all of them on the surface. So how about I go with 0.8 here, or I want to go with 0.85. And now I want to move them in a way that they're exactly inside, not on the edge, right? So see here, I want to go with move or translate. The geometry which is going to be moved are the scaled cylinders. I want to move them a little bit on the x direction. So to the x value, let me move this a little bit here. To the x, I can assign maybe I'll go with 0.5 meter or 50 centimeters. That goes to X translation. And I need to hide this so we can only see the outcome. There's still more room over there. I'm gonna go with 70 centimeters then. So it's more or less in the center, 80. And in the Z translation, actually 0.8, not and see what happens in the code block here. You have to put 0.8. 0.8 does not is not recognized by Dynamo, so 0.08. Okay, and to this other side, maybe I can assign 20 centimeters or 0.2 to the Z direction. I'm gonna also change this to 0.9 because there's still room over there, Z direction. Okay, now let's see. Now it seems that actually I need to move them a little bit more up, you see. So I'm going to go with 0.25. I want to make sure all the objects are inside. It's still not true on the Z direction. I might need to make them even a little bit more, a little bit smaller. So let's go with 0.8 here. Now I want to move them a little bit more up and more to the right. So I'm going to go with 1.2 here, and maybe we can go with 0.35 here. I still have more room. I want to go with 1.4 and 0.45 here. Okay, so now the objects are within the surface, right? And they are connected to the trimming entity. I want to hide this, but probably still not working. So you see the surface is not perforated yet. Why it did not work? As I mentioned, this is kind of, we have a lot of solids here. We have actually 108 and it's a list inside a list. We actually need to union these solids, so it would consider them as one single entity as it mentions here. So I want to go with union, and there is this option which is going to give you the union of the whole solids in a list. By union here, solid by union, this goes here, and this goes to my trimming entity. And of course I need to hide this to see if it's working. It still is not working, so let's see why not. Maybe the amount of extrusion is not enough, so I want to turn the preview on here. So First, we need to check if any of them is exactly on the edge, which is not. So we are good with that. Second, we need to see if the extrusion comes out of the surface, which it does. Right? So what I want to do here is that I want to go with another solid by union. I assume that would help. So let's check it. Just see if I turn the preview off here. They're not cut. So I want to go with by union again. I want to connect solids there and connect this to trimming entity. And now it's cut. So what happened here is that if I pin these nodes here so you can see better, basically here in the subtract from node, it expects a trimming entity. So when I union this twice, it's going to turn 108 objects into actually one. Although they are not overlapping, you saw there is a distance in between the cylinders. But anywhere is kind of actually making them into one solid, even though they are not overlapping. And now it would be able to actually assign it and cut it out of the surface, right? Let me clean here a little bit. So all these here that I have here, all these items are actually my cutting geometry. And what we have at the end is actually just the perforated nerves surface. And finally, we can thicken this surface. So I want to type thicken. This one, let's say maybe I want to thicken it by 0.3. This goes to thickness and geometry goes to surface. Now you see this is actually a perforated solid because we thickened it. And you can then work with different parameters that we had here. For instance, if you change the radius of the circles, it was 40 centimeters. If I change it to 30 centimeters, the whole pattern is gonna update automatically. If I change the radius of the attractor geometry, which you remember we had basically an ellipse over there, let's say maybe this one I want to change it to 7.5 for the x-axis radius of the ellipse. So whatever you do is gonna automatically update it on your pattern. And finally, how about I change this to manual for a second, and when you are done with the pattern, I'm gonna change this back to 40 centimeters. Feel free to import it. This is actually one single solid, so we can import it. This is one geometry. I can go with import by geometry, and as soon as I run this, it's going to import this into Revit. I imported this file into Revit. I'm going to close my Dynamo. So this is the surface in Revit. If you are interested to assign some materials or something, feel free to go to Manage, Object Styles, and you can go to Imported Objects. To this layer inside, whatever material you assign is going to be the material that it shows in Revit. If I change this to shaded, you can see better here.